Hello everyone, my name is Arun. Today we are going to take a look at linear regression using Python with the scikit-learn. So before we are going to the video, we must understand what is linear regression. So linear regression is a statistical set of statistical process to estimate the relationship between one or two more variables. So by using the linear regression, we can find out a relationship between variables and we can use that relationship to predict the future outcomes. Now I'm going to demonstrate how to use linear regression using Python libraries with the help of scikit-learn. First I'm going to import my pandas libraries for data manipulation purposes. Pandas SPD. After that I'm going to import NumPy also for mathematical calculations. Then I'm going to import a matplot library for data visualization purposes. Then going on from sklearn, I'm importing train test split to split my dataset into training and testing purposes. And for that I'm importing that library. So after that from sklearn, I'm going to import the linear regression which will perform the linear regression on my data. So after that finally I'm going to import metrics for performance evaluation of the model. So now I'm reading that data set. So pd.read CSV and I'm going to specify my file path over here. So it will read my data set. Now you can take a look at my data set here. So my data set contains salary details with experience. So you can see here the salary is getting increased gradually based on your number of experience here. I'm going to use linear regression on my data set and I'm going to see what it can do. Okay, now I'm going to take a look at my shape of the data. So it has 20 rows and 2 columns obviously, as you can see here. So after that, if you want to take a look at our statistical details of the data set, we can use describe. So here you can see the mean, count, standard deviation, etc. You can check out those details over here. Now let us plot our data points in a 2D graph. So I'm going to use a scatter plot for this. Scatter dataset dot experience, dataset dot salary, and y will be salary, and plt dot I'm going to put a title experience versus salary. I'm going to put my x label as experience and my y label as salary, and I'm going to show. Okay, now you can take a look at our data points, how it got scattered in our 2D graph. Our graph has a x value as a experience and y value as a salary. This is how our data points are scattered in our data set. Now we are going to use the linear regression to find out the relationship between this experience and the salary. So once we found out the relationship between these two, we can use it for our prediction. Now I'm going to assign my attribute experience to the x variable and my label salary to the y variable. So in order to feed into the model, now we have to split our data into training and testing set. I'm going to split into ratio of 80:20. So I'm now writing x train and x test, y train, y test. So I'm going to use train test split that I have imported back there, specifying my x and y variable. Then I'm going to put my test size equal to 0.2 proportion. Since I'm taking my training and testing set in the ratio of 80:20, we can take in any format like 60:40 or 70:30. So you have to specify your test size accordingly in the proportion. Next I'm going to put my random state equal to 0. So you can put any integer. It is just to avoid during multiple runs, we don't want our model to take different proportion of data for training and testing. So if we put any integer and we make it as a constant, so during multiple runs it will take only that set of data for processing. Now I'm going to assign my linear regression function to the regressor variable. So now I'm going to fit my training data set regressor.fit xtrain y train. So you can see here, yeah, obviously you will get a value error because these estimators expect always 2-dimensional array, but in our data we have a 1-dimensional array. So now I have to convert my data set to 2 dimension. So I'm going to put values dot reshaping minus bracket minus 1 comma 1. So it will reshape my 2-dimensional array into a single dimension one. So I'm going to put it on y as well. So once we are done, the value error got fixed. You can minus 1 comma 1. So I have to run it. So you can see here the error got fixed. Now you can take a look at my x variable here. So x, so this is how my 2-dimensional array got fixed. 1-dimensional got fixed into 2-dimensional one, and the same as well to y. Now the regression is applied on my training data set. So my regression has found out the best fit line for the prediction. So now I'm going to use the regressor to predict the values in the testing data set. I'm going to put regressor.predict, and I'm going to pass my testing variable here, testing data set variable, which is x test. I'm going to print the result now. Now you can take here, take a look at the array of results. So these are the results for the values in the testing data set. Now instead of using the testing data set, we can use our own input and we can get the output for that as well. For that we have to put regressor.predict and we have to put our input value over here. So I have to put open brackets and I have to pass the input variable here, and you can see the prediction for that as well. So the prediction for the 7 years of experience is 7183. Next we are going to plot our regression line from the prediction. So first we will draw the 2D graph that we have used before, and then we will plot our regression line on top of that. Now I am using the same scatter plot that we have previously used before. Dataset dot experience, dataset dot salary. I'm going to use the color as a gray for the data point. Salary, it should be capital S. Data frame has no, yeah, it should be capital S. Oh, it is good now. So next I'm going to plot the regression line. So dataset dot experience, regressor, and I'm going to predict dataset, and I'm going to pass the experience attribute over here, and I'm going to use the color of the line to red or ed. Okay, attribute error has no color. Okay, it should be or. Okay, so this is our regression line, and the gray ones are our data points. Now I'm going to label the x column as a experience, and I'm going to label the y column as a salary. Okay, this is done. Our regression line is now plotted. As we know that the equation of the straight line is y is equal to mx plus b. So where b is the intercept and m is the slope or coefficient of the x. So our basic functionality of the linear regression is to find out the best value for the intercept as well as the slope. If you want to print out the value of the intercept, we can do it by regressor dot intercept, and we have to run it. We can get the intercept value, and if you want to print out the slope value, we can print by putting the regressor dot coefficient. It will give you the coefficient of x or the slope of the regression line. So next, if you want to take the look at actual and the predicted values of our model, we can do it. So by this way we can analyze how well our model is performed. So we have to put I'm going to put df equal to pd dot dataset, and I'm going to specify actual. So under this label my actual values will get printed. I'm going to use white test variable, and I'm going to put flatten, and here I'm going to create a predicted label, and I'm going to put my y predict value into that. So once we run, okay, you have to put as a data frame, sorry. So here you go, you can see the list of actual and the predicted value. So the actual is 12,300 and the predicted is 13,223. It's still a good prediction. It's not a great prediction, but what we have is very good predictions. Next we are going to evaluate our model. The first thing we are going to do is we are going to find out its mean absolute error. So what is mean absolute error is it's a mean of the absolute value of the errors. We don't need to implement any formulas since our matrix library has all the predefined formulas. We just need to use it. So print mean absolute error colon, so comma, matrix dot mean absolute error for the variables y test comma y predict, and you will get the mean absolute error. So next we are going to calculate the mean squared error. So what is mean squared error is, it's a mean of squared errors. So here I'm going to use a matrix library. I am to put a mean squared, just to replace absolute with squared. Here you go, you will get the mean squared error value. It is close to 1326372. Okay, so after that we are going to calculate root mean squared error, or MSE. So it's the square root of mean of all the squared errors. So just I'm going to replace squared errors, and I'm going to replace this absolute with mean squared, and I'm going to use numpy, and I'm going to calculate the square root of this one. So once you are done, you just need to execute it. You will get the root mean squared error. So we can see here our root mean squared error is 1151, and our mean of the salary is 8777. So which is still more than a 10% of the 10% of the mean of the salaries. So this means that our algorithm is not very accurate, but still it made a very good reasonable predictions. So this is how we can implement simple linear regression in Python using scikit-learn library. Fuck her in the Benz.